So hey guys, hello and welcome back to the channel. This is me Pritham Paikre and you are watching Step 2 Math. So today in this class we will be discussing about how to solve a pair of linear equations in two variables. In last classes or in lower classes you have already came across the linear equations in two variables. So basically what are linear equations? In today's class I will be saying or I will be giving you the formal definition of a linear equation, and we will see how actually this linear equation looks, and we will also see geometrically how this linear equation looks. In few more videos we will see how to find the solutions of the pair of linear equations geometrically as well as algebraically. So without wasting the time, let us start our today's topic, the pair of linear equations in two variables. So let me give you the definition of a linear equation. So the equation of the form a1 x1 plus a2 x2 likewise an xn plus b is equals to 0 is called a linear equation, in n variables, and x1 x2 to xn, and a1 a2 likewise an b are real numbers. Okay, so basically in today we'll be just discussing about the real linear equations. That means the linear equation with coefficient my real numbers. I will not go to the complex number portion. Okay, so here I have given you the definition of a linear equation in n variables. Then what is a linear equation in two variables? So hence linear equation in two variables is given by a1x plus a2y plus b is equals to 0. Okay, so I will be saying, so this is my linear equation in two variables where x and y are variables and a1, a2, b are my real numbers. Okay, so they are my real numbers. So in earlier classes I have told you what is the notation for the set of real numbers. So I think it is not a very big issue to know. So this R is called my set of all real numbers. Fine. So now, in class 9 actually you have come across all these linear equations of one variables. So when I will be saying okay, give me an example of a linear equation, so I will be saying okay, suppose 2x plus 3y plus 5 is equals to 0. So yes, this is an example of a linear equation in two variables. So can you guys give me what will be a general form of a linear equation of one variable? So, and can you say what is the relationship between the linear equation in one variable and the linear polynomial? So it is a work for you. So you just go through that and see how a linear equation in one variable looks and how a linear polynomial looks. Fine. So but we will not go through that. So we will see how to solve these linear equations. So I will be saying okay, I will be having a solution, say some x naught y naught. Okay, I will be having a solution, say x naught y naught, such that 2x naught plus 3y naught plus 5 is equals to 0. I will be having if x naught comma y naught satisfies the equation, satisfies the f of equation. Okay, suppose this x naught comma y naught satisfies the above equation, then 2x naught plus 3y naught plus 5 is equals to 0. That implies my x naught and y naught, that means x is equals to x naught and y is equals to y naught, is a solution for this linear equation in two variables. So now the question comes. So how many solutions for this linear equation actually exist? So the answer will be yes, it is having an infinite number of solutions for this linear equation in two variables. Or for any linear equation, again if I will be saying general form of linear equation, so it is having infinite number of solutions. How to see this? So I will be saying, okay, let me first solve this algebraically. So I will say, okay, 2x plus 3y plus 5 is equals to 0. That implies my y is equals to minus 2x minus 5 by 3. Okay, so you can see y is equals to minus 2x minus 5 by 3. So if I will put x is equals to 0, that implies y will be equals to minus 2 into 0 minus 5 by 3. So it will be equals to minus 5 by 3. Okay, now you can see what? You can see if I substitute x is equals to, if x is equals to 0, y is equals to minus 5 by 3, then suppose this is my equation 1, then here x is equals to 0 and y is equals to minus 5 is a solution for equation 1. Okay, so I can say it is a solution for equation 1. So now, can I give another example or can I give another solution for this equation? So you can say yes. So if x is equals to 1, so if x is equals to 1, I can say it will be, so y is equals to minus 2 into 1 minus 5 by 3, so that will be equals to minus 2 minus 5 by 3, so it is minus 7 by 3. Okay, so it is minus 7 by 3. So that implies x is equals to 1, y is equals to minus 7 by 3 satisfies equation 1. Okay, so you will be saying, so this will also satisfy the equation 1. That implies what? That implies this is also a solution for the equation 1 or for this linear equation of two variables. So now, so then how many number of linear equation solutions are there? So I will be saying for different values of x, I will be having the appropriate y such that will satisfy this equation 1. That implies as I am having as I am independent to give the value of x, that is any real number. So and you know a real number, there are infinite number of real numbers. So I can say okay, so this solution, this linear equation has infinite number of solutions. Okay, so now if I will see how geometrically this looks, so let me just solve this. So you can say, okay fine, if I will draw this equation in the graph paper, so I will see, okay, so I will see what, so okay fine, so y is equals to minus 2x minus 5 by 3. Okay, minus 2x minus 5 by 3. So if I will solve this, so you will be seeing, so x, y, so this is, if I will be having x is equals to 0, so y is my minus 5 by 3, and if x is equals to 1, so my y will be equals to minus 7 by 3. Fine, so it will be minus 7 by 3. Okay, now I will be next I will draw a xy plane in the graph paper. So this is my x, this is my y. Okay, so I will be saying, okay, so 0, that means some 5 by 3, that means it will be little bit lesser than minus 1. So suppose this is at some point this. Okay, so next if I will see, it is when x is equals to 1, so I will be having y is equals to minus 7 by 3, means it is 2.33. Okay, so I will be saying it is minus 2.33. That implies it is somewhere else here. Okay, so if I will join this, Fine. So now this is my this straight line represents this equation 2x plus 3y plus 5 is equals to 0. That implies any point on this straight line, okay, any point on this straight line will satisfy my equation 1. So I will be saying yes, the numbers or the xy that are on the straight line, they are my solution for this equation. Okay, so fine. Okay, fine. So I hope this will be just revise all those things in today's class. So in the next class we will be seeing actually what is a pair of linear equation in two variable, and we will solve this pair of linear equations geometrically. Okay, and if in some more videos we will see how to solve this algebraically. For the time being, this is all about our linear equations. So stay tuned, stay safe. Thank you.